Imagine two of the most extreme objects in the universe on a deadly collision course. One, a black hole with gravity so intense it traps even light. The other, a neutron star, the crushed core of a once massive sun, dense enough to cram the mass of our sun into a sphere just 20 kilometers wide. Now imagine what happens when these titans collide. So today we ask, what if it happened closer? What if a black hole collided with a neutron star right in our cosmic backyard? A neutron star is created when a massive star explodes in a supernova. What's left behind is an ultra-dense core made almost entirely of neutrons. A single teaspoon of neutron star matter would weigh as much as Mount Everest. Now enter the black hole, a region of space where gravity has overwhelmed all other forces. Nothing, not even light, can escape. When a black hole and neutron star get too close, gravity becomes a ruthless matchmaker. The black hole's immense pull starts to stretch the neutron star. This process is called tidal disruption. As the neutron star spirals in toward the black hole, it emits powerful gravitational waves, ripples in space-time that travel across the cosmos. Depending on the mass of both objects, one of two things could happen. The neutron star is swallowed whole before it can even scream. Or if the neutron star is torn apart first, it forms an accretion disk, a swirling, superheated halo of matter around the black hole. This accretion disk can ignite intense bursts of X-rays and gamma rays, the most energetic light in the universe. Astronomers might detect it as a short gamma ray burst, a cosmic firework that lasts only seconds but outshines entire galaxies. So what if this collision happened within, say, 100 light-years of Earth? First off, we'd detect a surge of gravitational waves strong enough to jolt every detector on Earth. Next, space telescopes might catch a sudden flash of high-energy radiation. But don't panic. The odds of it affecting life here are vanishingly small. Even a powerful gamma-ray burst would need to be perfectly aimed at us to cause real harm. Still, it would be a spectacular light show, and a priceless scientific event. The aftermath of this cosmic collision? Most likely a bigger black hole, now heavier and spinning faster than ever. It may also be surrounded by a remnant disk of hot plasma, and possibly even eject matter into space at near light speed. These events help scientists understand how heavy elements like gold and platinum are formed. Yes, the gold in your jewelry may have been born in such a cosmic smash-up. Events like this help us probe the extremes of physics, gravity-matter energy. They test our understanding of Einstein's theories, nuclear physics, and the very limits of how the universe works. And they remind us just how alive and dynamic the cosmos truly is. A black hole colliding with a neutron star isn't just an explosion. It's a window into forces beyond imagination. And who knows, maybe one day with better telescopes and detectors, we'll witness one, not just in data but in real time. Until then, we watch the skies. For more videos like this, visit and subscribe to Knowledge Hub.